So day 2 of the chain rule, 2.4, day 2, part B. Trig functions and the chain rule. So we already know how the chain rule works, kind of. Now we're going to throw some trig functions in there and do some questions with trig and chain thrown together. All right, we already know 2 of the trig function definitions, or 2 of the trig function derivatives, I should say. What's the derivative of sine? Cosine. By the way, for this, usually I don't really care how you take notes. I care that you take notes, and all of you do. But for this one, you should lay it out like I'm going to lay it out, because there's a lot of similarities between, these sort of come in pairs. So strongly suggest you lay out your notes like I'm going to lay out my notes, because I think it will help you remember what the derivatives are. So next to sine, to the right of sine, let's write what the derivative of cosine is. So what's that one? Negative sine. So we've seen those 2 already, but seeing those again will help establish a pattern as we learn the rest of these. Derivative of tangent. I'm not even going to ask you to guess, because there's likely no way you would guess this, but the answer is secant squared. Not that you would, but if you wanted to prove to yourself that that was right, you could rewrite tangent as sine over cosine and then use the quotient rule. And it would take some trig and some algebra and some time, but eventually it would reduce to secant squared. Derivative of cotangent of x. I don't know if there's enough of a pattern there yet to make a guess. Negative cosecant squared. Cosine became negative sine. Secant's going to become negative cosecant squared of x. And then lastly, the derivative of secant is secant x tangent x. That's another one where you could derive that if you wanted to. You'd rewrite secant as 1 over cosine, do the quotient rule, and eventually land there. Most people don't do that. They just memorize derivative of secant is secant tangent. Okay, pattern followers, pattern recognizers. Based on what you've seen so far, care to take a guess at what the derivative of cosecant is? Is it positive or negative? Negative. What do you think? Close. Switch that one as well. So cosecant x, cotangent of x. That gets the big red box, stars, and whatever else you want to put on there. You got to know those, and you'll have to know those all year long. Now, those are a little bit less important for 2 reasons. One, you don't see them that often, but 2, if you memorize the first 4, or at least those 4, you can figure out those 2. So most people don't memorize those 2. They just remember that there's some sort of pattern here. Definitely memorize derivative of tangent and derivative of secant, and then you can figure out the others if and when you need them. All right, so let's put some things together here. Let's put chain rule and trig rules together. So cosine of 2x cubed. So what do I want to handle first? What's the outer layer of my blow pop there? The cosine or the 2x cubed? The cosine. In fact, this is a little bit overkill, but some people will even label these. Like, I'll do the cosine first, and then I'll do the 2x cubed. I mean, that's a little much, but that's at least what your brain should be thinking when you see that is, well, what order am I doing this? Work from the outside in, just like with the blow pop. So derivative of cosine is negative sine. But once you've done a derivative, you only do one derivative, right? You only eat the blow pop one layer at a time, so leave 2x cubed alone. Once you finish the wrapper, then you move to the next thing, the derivative of 2x cubed. What's that going to be? 6x squared. And then that's a perfectly reasonable safe stop. I think the only thing a back of the book might clean up is put the 6x squared in front, just because it looks better. But that would be an easy one. If you wrote this down and then started looking at answer choices, you would recognize that pretty quickly. Example 2. Tangent of the square root of x. There's two issues, at least two issues in this one. What are you going to do first, the tangent or the square root? What are you going to handle first? The tangent. And then I don't like square root, so I'm going to rewrite this. What power is the same thing as a square root? 1/2. So you may get to the point where you recognize that and you handle it kind of on the fly, and that'd be great. But until then, I'm going to rewrite it. So tangent is the outside wrapper this time. So I'll do that first, and then I'll handle x to the 1/2 after that. In fact, why don't you try that one? We've got it all set up. See if you can do that one. So there's the answer to example 2. Again, handle the tangent first, then chain rule that onto the derivative of x to the 1/2. Example 3 is going to be sort of in comparison to example 2. So example 2 was tangent of the square root of x. Example 3 is the square root of tangent of x. All right, so they both involve tangent, they both involve a square root. It's a matter of who's the outside layer. So who's the outside layer on number 3 here? What's sort of the outermost function we're going to worry about? The square root. So wrapper first, square root first. And again, I don't like square roots. I'm going to rewrite that as a power. And again, if you've done it enough that you don't need to do that, you can handle the square root, that's fine. But technically, we don't take derivative of square roots, we take derivatives of powers. If you can make the switch in your brain, then fine. I'm probably going to keep writing it for a few more weeks. All right, why don't you try that one? Again, outside in, so now you're going to do the 1/2 first, and then you'll do the tangent. Test will have both types of questions, and if you get a free response question, you do not have to clean it up. Once you're done with calculus, be done. Don't keep going and risk messing something up. So take advantage of the safe stop. Obviously, in a multiple choice, we're going to clean it up to force you to clean it up. Example 4. See how many chains we can link together on this one. Cotangent cubed of 2x squared. Well, 5 times cotangent cubed of 2x squared. So I got a lot of things going on here. This is really closer to the blow pop example, because I've got an outside wrapper, I've got the candy, and then I've got the bubble gum. So for this particular problem, what am I going to handle first? See, my options are the 3, so the cube, the cotangent, or the 2x squared. What am I going to do first? The cube. So one layer at a time. Let's handle the cube thing first. In fact, let's lay it out ahead of time. So I'll do the cube thing first. So that peels off the layer. What's the candy layer? That peels off the wrapper. What comes next? The cotangent. So I'll do the derivative of that second. And then lastly, I'll take care of the 2x squared. That's my bubble gum on the inside there. So this is really going to be chained together here. Okay, 5's a constant. He can just go along for the ride. Handle the cube. By the way, if it helps, some people would take the time to rewrite this like that, because I think then it becomes really clear that the 3 is the outermost thing. So, I mean, those are identical, but if you rewrite it like this, it's super clear how to start from the outside and work your way in. All right, so the 3 comes down front, because don't worry about the inside, we got something cubed. So the derivative of something cubed is 3 times the thing squared. And don't mess with the inside, one layer at a time. So cotangent of 2x squared. Alright, that was link 1 of the chain. Link 2 will be the derivative of cotangent. Let's see, tangent goes to secant squared, so cotangent goes to negative cosecant squared. That's the derivative, so don't do more than one derivative at a time. Leave the 2x squared alone. And then lastly, we'll chain on the derivative of 2x squared, which would be 4x. There's your safe stop. You could be done. I don't know that there's a whole lot you could do to clean it up, other than multiply all the numbers that are there, 5, 3, and 4. 15 times 4 is 60. There's a negative sign. Yeah, we should probably put the x in front. I guess if I'm really being clever, I could put the 2 on the cotangent squared. So that's the fancier way to write it. Times cosecant squared of 2x squared. That's another one where getting from free response to multiple choice I don't think would be too big of a deal. Especially on multiple choice, because likely one of the answers is going to be, okay, this is one of those things, don't write this down. Simply not even record it. Here's the danger that people do. They try to eat it all at once. So 5 times 3, but the derivative of cotangent is cosecant squared of 4x, something like that. Like you try to just sandwich them all at once, and it doesn't work. One layer at a time. Chain rule is probably the most, not the most missed thing all year. It's maybe the most consistently missed thing. There's people who will mess up the chain rule in March and April, even though we continue to do it. They forget to go one layer at a time. Later in the year, if I pass back a test and give you a blow pop with it, it means you messed up the chain rule. And some people think it's funny when I do that, and other people get disappointed because they know if they get their test back with a blow pop, it's not, hey, congrats, here's a blow pop for making 100. It's, hey, you forgot the chain rule. Here's a blow pop to help ease your pain, but also remind you of what you did wrong. One student last year, it got to the point where I gave them a blow pop at the beginning of a test, just to make a scene about it. They didn't mind being called out because it also reminded everybody in the room, hey, don't forget, chain rule. We got to remember that all year long. Last example. Find the equation of a tangent line. Find the equation of a tangent line. Whoop, let's pause there. So I'm going to need a slope and a point in order to write this tangent line. And how I get the slope is with the derivative. So this is just a sneaky way, or not so sneaky way, of getting me to find a derivative. Find the equation of a tangent line to f of x equals x cosine x minus sine of x at pi over 2 negative 1. So anytime I'm asked for a line, I need to find the slope and a point. And then I'll write point slope form. Well, I've got the point, so that's a check. And the slope I'll get from the derivative. So in some ways I'm halfway done because they gave me the point, but the slope will be the harder part. So f prime of x. How am I going to have to do x cosine x? What rule is that going to require? Product rule. So you got all these rules and you got to keep them all like at the forefront of your brain and recognize, well, when do I use which one? So I'm multiplying, so I'm going to do product rule. Can I try to product rule on the fly, or do you want me to write it out? You got it. Write it out. So we'll call the first one f, the second one g. F prime would be 1. G prime would be derivative of cosine. What's the derivative of cosine? Negative sine. Okay, it's product rule, so the order doesn't really matter. First times derivative of the second plus second times derivative of the first. Am I done with the derivative? This is kind of a tricky one. Maybe. So we did the product rule on this guy. Don't forget there's more to this function though. Let's see, the derivative of sine would be cosine. So that's the easy part. It's just once you've done a complicated piece, sometimes you forget about the rest of the function to do. This worked out kind of nice because cosine minus cosine went away and we're left with just negative x sine of x. Okay, what's the point? Like, where am I going with this? What do I need to do next? Plug in what? Plug in pi over 2, because that will tell me, what will that tell me? The slope at that point. So the slope at x equals pi over 2 would be f prime at pi over 2. So plug in pi over 2. And if we really wanted this to be ugly, we could leave that as the slope and just use that as the slope, because that's a safe stop. But we know what the sine of pi over 2 is, right? Especially once you draw the picture of it. 1. So my slope is negative pi over 2. So I've got a point and a slope. Y minus y1 equals m times x minus x1. So y plus 1 equals negative pi over 2 times x minus pi over 2. And you can leave it like that. That is a perfectly good stop. We like point slope form because we don't have to do anything else with it. All right, the assignment is from page 136 because we're still chain ruling here. 43 to 59. Yes. And I'm going to make a slight change to because what I have written on here, 43 to 59. Hold on. EOO. And then 73 to 81 odd. Yeah. You know what EOO stands for? I haven't used that in here yet. Any guesses? What'd you say?
Even, odd, odd.
Even, odd, odd. That would be a tricky thing to keep up with. It's not even, odd, odd. But the last O is odd. Every other odd. So it's a way to cover a bunch of problems without doing all of them and without even doing every other one. So every other odd. So we'll do 43, but we won't do 45. We'll do 47. We won't do 49. We will do 51, and so on. The hardest part about that is keeping up with every other. Because if you miss one, then you end up doing the wrong every others, which really isn't that big a deal because it's still good practice. All right, so Wednesday we'll review. Thursday we'll test. And Thursday we'll just make all the homework due. I wasn't here, didn't want the sub to have to deal with it, plus getting it back to you and graded, all that stuff. So we'll just pick up all the homework on Thursday. You've got the review worksheet. So tomorrow I'll answer questions from page 136 and from the review worksheet, and we'll have some warm-ups. So hopefully after tomorrow you'll feel good about what's on this test.